Hello, I'm Eric Pollinger, and welcome to my final project for Intro to Digital Logic and Hardware Architecture. I decided to write in assembly language a program for the AVR processor to control 4 traffic lights at an intersection using sensors and a radio transmission from a potential ambulance. So you can see in the picture here, we have the intersection, the idea being that A, B, C, and D represent both sensors and lights. And in the case of an ambulance traveling east on Bin Road towards the hospital, it can send a radio signal which will cause the lights to momentarily turn red, and then for the A light to turn green for the ambulance to pass. You can look at my Word document for further details about the actual requirements. The program itself, again, is implemented in assembly. I'll just go ahead into debug mode to specify what's going on here. So before we get started, the input is coming in via port B. Basically, the sensor can sensors all come in via the single port. Depending on the bit being flipped, we have sensor A through D, or if the 5th bit is set, that is the radio signal from the ambulance. The output to the 4 lights occur on ports C, D, E, and F, and they correspond to this arrangement. So setting the first bit specifies green, second bit yellow, third bit is red. So before we get in here, let's go ahead. I do have a stimulation file, a very simple one. So in this case, I'm just, for now, switching pin B to 0. So there are no sensors being triggered. So basically what the main loop is doing is going through the sensors one at a time, starting with A and going through D, and verifying whether or not the sensor has been set. So I have created an alias to some of the registers A, B, C, and D. So we're going to put the sensor information into A. Then what we're doing here is we're going to AND it with the bitmap I just showed you for sensor A. So this will result, if that sensor is set, in A being identical to sensor A. And it has the effect, should other sensors also be triggered, it will zero them out. So here we load back the original sensor A information to B. This is a compare and skip if equal. So if A and B are equal, that means that sensor A has been tripped, and in this case we do want to set a green light. But as you can see, we're not skipping the next line because no sensor has been set, and we are going to continue on to state B. Now B would normally do the exact same thing, and we'll continue on to state C, but let's go ahead and set pin B to 2, so this will actually trigger the green light. So that's actually, it did set pin B, but I think I might have done it a little too late. A may not have gotten set. Yeah, so in this case, I did set it, but it took 1 extra clock cycle to do it. So let's see if we can do the third sensor instead. So the third sensor, okay, so I think I did the same thing at the third sensor. So let's go ahead and reset it so that sensor D, using 8 for pin B input, will be the sensor that gets triggered. So as we come to D, you'll notice that the compare is seeing the two as being equal, so it skips the jump and then goes into the signal and sets the light to green, as you can see on the right side. If you look up port F, so you can see that turns from red to green, bit 1 being set. We now step in to the delay. Now this is the 10-second delay. I am using the internal timer for this. So I have the prescaler set to 1024. So at 1 megahertz, it's 256 iterations at 1024 per iteration. That makes up approximately a second. It's 1.05 seconds. That said, you'll also see that I've got count 40 and then count 2. The idea of count 2 was just to slow things, to quicken things up for testing purposes, because in emulation mode it still takes a long time to get through this. Now you can see we're down in the pause routine, so we're just going to continue through the pause routine. You'll notice that there's a remote call being made there to the A and B check. That is the check on the ambulance port to see if the radio signal came in from the ambulance. So it'll actually sit here for a fairly long time trying to get through the full 10 seconds, which amounts to probably 8 or 9 minutes of real time on the simulator. So I'll go ahead and set the sensor so that the ambulance, to simulate the ambulance call having been made. So the ambulance is set for the 5th bit, so that would be 16. So you'll notice I'm still in the pause routine here. Basically what's happening here is that we're able to detect the ambulance in one of 2 locations. One is this location as part of the delay, and the other one is at the end of checking the main 4 sensors, should all 4 come through as untriggered. So here we are in the ambulance check. I'm conducting the check basically the same way, but instead of returning, it's going to handle the ambulance code. So in this case, we're going to set all the lights to red, and we then initiate a 2-second delay. This 2-second delay again takes a long time since we're in simulation mode, so I'll just explain what happens after that. As you can see, we do set A for green, the A light to green, the ambulance comes through. It's given a 10-second window. Now in this case, we do iterate through the 1-second delay, because the 10-second delay would pick up on the ambulance being triggered again. And it would constantly just reset to this point. So this is a bit of a hack, and we're just going through the 1-second delay rather than the 10-second delay. It also represents the one known bug I have here, in that when we're in the 1-second delay, we're not actually picking up on the ambulance. So potentially the ambulance signal could go up to a full second before being recognized by the system. That's something I'll take care of later. Otherwise, you'll notice at the end of this, if we do handle the ambulance, we will go ahead and reset all the way back to main, and that will cause a full reset, and all the lights will go red momentarily, and then we'll start again at the A port, and we will make our way through all of the different sensors. So like I said, I do want to fix the yellow light, the 1 second delay, because that should pick up on the ambulance as well. Also, for a production app, I would need to retune the timers. They go for approximately 10 seconds and approximately 1 second, but I would make those exact by, instead of just taking the overflow bit, you would have to dive into that last one and figure out just how many clock cycles you would need to take in order to produce the proper second. I did also find that the debugger is pretty powerful, but it was a little frustrating that I couldn't get, for example, the port to be specified under the watch variables on the bottom of the page. Rather than specifying the actual value of port F, they would return a specific hex value, and I wasn't entirely sure what that was because it didn't correspond to either the value or the address, as you can see here. Can 8B? Yeah, I'm not sure exactly what that is specifying. The other aspect here is under the processor tag on the right, the upper right, you'll find some really valuable information on just how long the processor is running. So when I'm trying to tune to create a full second, this is basically where you would work. So you're looking for a million US in order to get 1 full second. So even at 1 megahertz, operating on a fairly powerful Windows system, the simulator isn't capable of even approaching a full 1 megahertz speed. Anyway, thank you very much for your time, and look forward to any comments or suggestions that you have on this project. Thank you much. Bye-bye.